So we're going to be talking about how to do proofs, and these are going to be just like the proofs that we were doing together last week, where we have special angle pairs and they're either congruent or they have a sum of 180 degrees. That's what we're going to do together. Let me go ahead and flip my camera on my paper and get you started. All right, so you see how on these notes I've got all of the names of the angles that we've been talking about.
It's upside down.
Oh no, goodness, let me fix that. There you go. Is that better? Okay. So what we're going to do is we're going to do proofs. So up here, my learning target is we will prove that the angles are congruent or supplementary. Okay. So here are all the angle pairs that we've learned about that are created when a transversal crosses parallel lines. So if one of these pairs is created by some parallel lines, then there's some things that we know will be true. Corresponding angles will be congruent. So I'm going to write, here, let me get a better marker. I'm going to write the congruent symbol right here. Alternate exterior angles will also be congruent. Alternate interior angles. See how I'm abbreviating? Alternate is ALT and interior is INT. I abbreviate it like that because when you write the proof, it's hard to put a long word in the space that they give you. So I shorten the word, okay? Next, it says same side exterior, EXT for exterior angles. Those are supplementary. So I usually write plus sign 180 to show that I know that those add up to 180. And then same side interior, those are also a sum of 180. Okay? So I know you learned all of that last week, and you already took your quiz with me about it earlier this week. So I know that's just review for you. When you go to do a proof, they're going to state your known facts, and they're going to call those known facts givens. And usually the givens will be parallel lines. Then you'll have to figure out some congruent or 180 sum angles and look for what it is you're trying to prove. There will be something that connects the things together. Because when you write a proof, it goes from one step to the next to the next. So you're always looking for what links your thoughts together to help you get to the final step. This right here, where it says see inside a proof, what I'm trying to do is help you see the different ways that things are written inside of a proof. See how this says a little A and then two lines and then a B? This symbol is the parallel symbol. So this is saying that line A is parallel to line B. And then that would be a given fact. And then this is saying angle 1 is congruent to angle 8 by alternate exterior angles theorem. So that's just kind of the way the symbolic language is written down. Okay, so I'm just trying to help you see what to look for. All right, we're going to start an example together now. So this example at the bottom of my page, it says, given, which is your known facts, given A is parallel to B, and then it says diagram above. So what I'm saying is use this diagram here. So there's line A and there's line B. Those are known to be parallel lines. I want to prove that the measure of angle 1 plus the measure of angle 7 is 180 degrees. So let me look where that angle 1 and angle 7 are located on the diagram. Here's angle 1 right there. Here's angle 7. So those are not one of my special angle pairs. So there's no reason why I could show that they're congruent already, or that they have a sum of 180 already. I have to get there in a roundabout way. So let's go ahead and start this. We're going to write down A is parallel to B, given, and then notice that they filled in some of this for us. So they're saying angle 1 is congruent to angle 3 because those are vertical angles. So the vertical angles theorem. Let's look where 1 and 3 are. Here and here. So vertical angles are the kind of angles you get whenever two lines intersect. Those are across from each other and they are congruent. So they're going to use the fact that those are congruent in a moment. They're kind of setting up their chain of steps. The next thing is going to say something that uses same side interior angles. And then this last step says the measure of angle 1 plus the measure of angle 7 is 180 degrees. Substitution. So I don't know, but I think you remember that substitution is what you do when you replace something inside of an equation.
Yeah, I do.
Yeah. So look at this. See this angle 1 up here, and then there's an angle 1 down here. If they've done a replacement, it has to be from something that you know is equal. So they've probably taken what used to be angle 3 in the equation and replaced it with angle 1 right there. So if I go backwards from that, I can put angle 3 where the angle 1 is and just rewrite everything else the same. Okay? Now let's look at this. 3 and 7 has a sum of 180 by same side interior. Let's go see if that's really true, if we guessed right. So 3 is here and 7 is there. So yeah, those are same side interior angles. Are you able to see that, or do I need to zoom it in?
I can play okay.
Oh, good. Okay. So the thing that we have to understand about doing these kinds of proofs is that when you start out with a pair of angles like this 1 and 7 that have no relationship here and here, then you're going to have to use the ones that you do know, like all the ones that we learned last week, the alternate interior and the alternate exterior and the same side interior and the same side exterior. You have to use all of those to help you get to that thing that you want to prove, okay? Look at the thing we were trying to prove. It has a sum of 180. So the thing that we used right here also has a sum of 180. So the only way to do a proof of something that has a sum of 180 is to use your angles that have that 180 sum. And the only ones that you know that do are your same side ones, right? Your same side interior and your same side exterior. Those are the ones that have that 180 sum. So if you're doing a proof with the 180 sum, you use your same side angles to help you get there, okay? Now we're going to do one a little bit more complicated because they're not going to give us as much information to help us. In this one, they say A is parallel to B, given. So I'm going to write that as my given. And then you can see on the next line, they used vertical angles somehow, and you have to figure out what to write there. So that's going to be some angle is congruent to some angle. You just don't know what. And then on this line, if we're going to be doing this a lot like the one I just talked with you about, do you remember the one we just did had substitution in the end? And so those two lines look almost the same because of that substitution. So let's look. Yeah, that's exactly what's happening again. It's going to be a substitution. So it's going to be measure of angle something plus measure of angle something equals 180 for it to be a substitution, right?
Yeah.
So now our job is we have to figure out what two angles could we put here and here. We have to use either 2 or 8 if a substitution has happened. Because when you do that substitution, you only replace one of the numbers, right? So either 2 or 8. Now we're going to go look at the diagram and we're going to see where 2 and 8 are. And we're going to decide, can we get a supplementary from either 2 or 8? Here, I'm going to zoom a tiny bit. So here's my 2. Here's my 8. If I use the 2, the supplementaries are the same sides. So if I use that 2, 2 is on the interior. What angle is same side interior with 2?
5.
Yes, awesome, 5. So if I use that, it will probably work. So I'm going to zoom you back out. And I'm going to put angle 2 plus angle 5 in here. And I'm going to say same side interior angles theorem. I know that looks weird the way I abbreviate it, but you see now why I have to do that. It won't fit if I don't abbreviate. And now I've got it all set up where 2 is the same here and here, but 5 has been replaced by 8 when I did the substitution, which means that the 2 angles that need to be up here need to be, if it's going to be vertical angles, hopefully 5 and 8 are vertical angles. Let's go look. 5 and 8. So yes, those are vertical angles. So let's put 5 and 8 right here. Okay?
Yeah.
So this is a lot to think about, but you can do it. It's a little bit challenging, but I know you love a challenge. Let's do one more of these, and this time they're not going to give us any hints about what they want us to do. But you know what that means is it's all up to you. There's not one right way to do it, and you can do it whatever way you like. So first thing I'm going to write down is my given. A parallel to B. Line A parallel to line B, given. And I know the thing I want to prove is that the sum of angle 3 and angle 6 is 180. So I'm going to put that at the bottom. And we know it's probably going to be substitution, but I don't want to write that in pen because what if I have to change it? So I'm going to wait on that. But if it is substitution, then this will be measure of angle something plus measure of angle something equals 180. And we know we want to use either 3 or 6. So we're going to go look at that diagram, and I want you to tell me either 3 and another angle or 6 and another angle. It's all up to you. They have to add up to 180. So either 3 and something or 6 and something.
Wait.
3 and 7. Okay, let's do those then. So let's put 3 here, 7 there. And those are what kind of angles? 3 and 7. Let me go back to it so you can see them. They were right there. So yeah, same side what? Nice, same side interior. Okay, so same side interior angles theorem goes there. And this is going to be substitution because we did replace the 7 with a 6. So now this line needs to say angle 7 is congruent to angle 6. And we have to go look for a reason why. So let's go look. Here's 7. Here's 6. 7 and 6. So what kind of angles are those? I needed to have a reason for saying that they're congruent. So I have to be able to name 7 and 6, what kind of angle pair they are. They're called vertical angles. Vertical. That's an older thing that we learned a while ago. So whenever two lines intersect, you have these two angles across from each other are congruent, and you have these two angles across from each other are congruent, okay? And those are called vertical angles. Vertical. Okay, so that proof is done too now. Do you feel like they're starting to sound more
why?
easy to understand?
Yeah.
Good. Okay. So let me do, you feel like you could do at least 1 or 2 more with me?
Yeah.
Okay, awesome. So here's another one. They're still using that same diagram over and over, but it's asking you to do different things each time. So here's one that it still says A is parallel to B because it's that same diagram. And then it's saying that they want you to prove the measure of angle 1 plus the measure of angle 7 is 180 degrees. And this time I am giving you some hints. I want you to use substitution, so you know it's going to be measure of angle something plus measure of angle something equals 180 if you're using substitution. And they also are telling you they want you to use a linear pair. Do you remember linear pair? Linear pair is whenever two lines intersect. Linear pair is these two that are adjacent next to each other. That's linear pair. And the reason they call it a linear pair is because there's a line on the side. So together the pair makes a line on one side, linear pair. So they want you to use that because how many degrees are in a straight angle? 180. So that's another choice that you can use. You don't always have to use same side angles. You could use linear pair. All right, let's go to our diagram. Remember, we're going to look for something like angle 1 or angle 7, and we know it has to be a linear pair, okay? So go check this out. You're looking for an angle that is linear pair with either 1 or 7, and you have as many choices as you want to make there. So I think, let me look. There's 4 different right answers that you could put. So pick any linear pair that is including either 1 or 7.
No.
7 and which one?
Oh.
Did you say 4?
No.
5?
No.
Okay. 7 though?
Yeah.
7 and what?
No.
2?
Yeah.
Oh, 7 and 2 are alternate interior. So remember, a linear pair looks like this, where it's two angles right next to each other on the side of a line.
11, 5.
Yep, 7 and 5. So I'm going to write 5 here and 7 there. Let me zoom out. Okay. I'm writing 5 here and 7 there just so I can easily see that the 7 is staying in the same place, but the 5 is getting replaced with a 1. So 5 and 1 are congruent because they are, no, I'm sorry. They're not congruent. They're silly me. What am I saying? 5 and, oh, look what I just did. I meant to write this up here and I wrote it down there. Oops. Let me just, I'll move this down here. It'll be okay. Sometimes it doesn't matter what order you write the things in as long as you have all the steps there. And this is one of those times. So if I replace the 5 with the 1, I say angle 5 is congruent to angle 1. So let's go look at angle 5 and angle 1 and decide why that's okay. Here's 5. Oops, sorry. Here's 5 and here's 1. So what are those called? One and 5. What kind of angles are 1 and 5?
Oh, no. Oh.
It's not alternate because 1 and 5 are on the same side, and it's not same side either. It's the one that has 1 on the inside, 1 on the interior, and 1 on the exterior, and they're both on the same side of the transversal. Sometimes I call them in and out angles. Corresponding. Is that what you were saying?
Yeah.
Yeah, awesome job. Okay, so now, oh, I'm still zoomed in, I'm sorry. So now we have it done. We have angle 5's congruent to angle 1 by corresponding. And then you have your 5 plus 7 is 180 linear pair. And if you put these two statements together, you can do your substitution. Okay, let's do one last problem together. This one here says, you're going to be so surprised. What does it start with? A is parallel to B every single time. Okay. And then if we're doing substitution again, we need to look for something that uses either 4 or 5 that's a 180 sum. So we're going to look for either linear pairs or same side interior or same side exterior with 4 and 5. All right, let me zoom you in. Whoops. Okay. So here's 4 and here's 5. Just pick either one of those. And then once you choose one, you can either pick a linear pair or a same side pair.
5.
Okay. So with 5, do you want to do a linear pair since that's one that you've been working on just now? What is a linear pair with 5? 7? Okay, we can use 5 and 7 again. So let's do measure of angle something plus measure of angle something is 180. Let's put our 5 here to show that that's staying in the same place. And let's put our 7 there.
I can't see it.
Oh, I'm sorry. I forgot I zoomed out. Okay. Or zoomed in. There. Is that better?
Yeah.
So I did the 5s in the same place and I put the 7 over there. Okay. So 7 was replaced with 4. So the line before that needs to be saying that 7 is congruent to 4. Now let's go look at what kind of angles 7 and 4 are. All right, so here is 7, here is 4.
Yeah.
7 is here and 4 is over there. So nope, they're not a linear pair.
Cool.
Yep, corresponding. Nice job. Okay, so let's put 7 and 4 are corresponding. Then we have our line where it says 7 plus 5 is 180. That was these two. So what is 7 and 5? Here, I forgot to zoom. 7 and 5 is called what? 7 and 5? What is that called?
Same line.
What did you say? I didn't understand. I'm sorry.
Name lại em liệu.
Something interior?
Yeah.
Oh, no. Look, 5 and 7 are right there next to each other. So they're a linear pair.
Oh.
I wasn't going crisscross like that. I was going right next to each other. So 5 and 7. Yeah. So I'm going to write linear pair. Oops. Linear pair. And now what should be my last reason that I put right here?
No.
Substitution. Yep. All right, you made it through. We did 5 proofs together, Connor. That's a lot. So I'm going to go ahead and hit the stop button so that this is the end of the video. And we'll talk about what we're going to do next time.